Okay, here is problem 2 from our review sheet. Romeo throws a present up to Juliet, who is standing on a balcony 10 meters above. At the same moment, Juliet drops a rose to Romeo. The present and rose collide 10 meters from the ground. So before I do anything, I want to draw a little picture of what's going on. And it's going to be very simplistic. Okay, so here's the balcony. Balcony is 10 meters from the ground. The present rises 3 meters. They collide at that point. So that means that my rose drops 7 meters while my present rises 3. Now, I want to make one statement about the present. Nothing in the problem says that that's the maximum height the present would have gotten to. If the rose had not collided with it, it would likely continue to have risen. Okay, we don't know exactly how far, but it would have. So we're not saying that that's the maximum height the present would have. Okay, so now let's get to our questions. What is the initial velocity of the rose Juliet drops? What is the acceleration of each object? How long does it take the two objects to hit each other? And then what is the initial velocity of Romeo's present? My first two questions are very easy to answer and don't actually need any math. For part A, what's the initial velocity of the rose? Well, Juliet drops it. Since she's dropping it, its initial velocity is 0. Okay, no math involved. B, what's the acceleration of each object? Now, acceleration here, we're talking about free fall. The two objects are in a state of free fall. Therefore, their acceleration, both, is the acceleration due to gravity, negative 9.8 meters per second squared. Okay. Now, you might be thinking, but wait a minute, the present is rising. True, it is rising, but its acceleration is still directed downward. Okay, gravity always is negative 9.8, unless we're not on Earth, but we are. All right, so now let's move on to one that's going to actually involve a little bit of math. How long does it take the two objects to hit each other? There's not a lot that I know about Romeo's present, but I do know a bunch of things about Juliet's rose. I know that the rose is going to fall for 7 meters. And that's all I need to know to solve this. So I'm not going to think about the present at all. I'm just going to say VF, VI, A, T, and Y. Why? Because, well, we're in free fall. I know what my initial velocity is. We already said that was 0. My acceleration is the acceleration due to gravity, negative 9.8. And I know that my rose is dropping 7 meters. So I have to be sure I have my negative sign there to indicate that it's dropping. I don't care what the final speed is. I don't need it for anything, but I'm looking for the time. Now, since I'm looking for the time, I have two equations that I could choose from. I could choose VF equals VI plus GT, or delta Y equals VIT plus 1/2 GT squared. Now, the reason I am going to choose to cross out that equation is because I don't know VF. Since I don't know VF, I can't use that equation because it would give me two unknowns. I am instead going to use this equation because even though my VIT drops out, I'm left with Y, which I know, 1/2, which is a constant, G, which I know, and then I'm looking for T, so I have everything that I need. So let me manipulate my equation. Okay, first of all, it's going to be delta Y equals 1/2 GT squared, which means that's going to be 2 times delta Y divided by G equals T squared. So I'll just take the square root of both sides. And now all I have to do is plug in. So 2 times -7 meters divided by -9.8 meters per second squared. Negatives drop out. T works out to be 1.20 seconds. So now I know how long it takes her rose to go from her hand to where it collides with the present. Now that gives me also a very important piece of the puzzle about Romeo. That is the same amount of time that the present is going to go from his hand to where it collides with the rose. So my final question is, what was the initial velocity of his present? So let's make up another list, a list for Romeo. VF, VI, A, T, and Y. I automatically know what my acceleration is because it's the acceleration due to gravity. We just said that the time that it's going to take is 1.2 seconds. And if I look at my little diagram, my present is going to rise by 3 meters. Since it's rising, I'm going to make that a positive. I don't know my final speed. Remember, we said we can't assume that it's 0. And I'm looking for whatever my initial speed is going to be. So I have to decide which equation to use. Well, again, since I don't know final velocity, I can't use either of my VF equations. VF equals VO plus GT, or VF squared equals VI squared plus 2GY. Okay, I don't have the final speed, so I can't use either one. That means I'm going to have to use the same one we did for the rose, VIT plus 1/2 GT squared, and I'm going to be solving for VI. So I'm not going to manipulate my equation the entire way. I'm just going to simplify it a little bit. So delta Y minus 1/2 GT squared equals VIT. So that's going to be 3 meters, and again, the 3 is positive because we're rising, minus 1/2 times gravity, so that'll wind up becoming positive, times my 1.2 seconds squared equals my VI, which I'm looking for, times my 1.2 seconds. Okay, so I hit this into my calculator, and this works out on this side to be 10.1 equals VI times 1.2, which gives me 8.4 meters per second. And that is how fast Romeo threw the package up into the air. Now, if I want to, I could figure out, well, how long would it take the package to come to rest if it hadn't hit the rose? But the problem doesn't ask me for that, so I don't need to. All right, come back for problem 3.